Welcome back to Made Up of Wires. We're decompiling Castlevania Symphony of the Night. If you're not familiar with the Castlevania Symphony of the Night decomp project, go to soten.z.dev, xee.dev, and you will find progress of the overlays that we've worked on, or are being worked on. You can also find a link to GitHub and a link to the Discord. We've been working on the, Sword Familiar, and we're going to keep doing that today. Yesterday, we spent a bunch of time. Here's our Sword Familiar. We spent a bunch of time looking at one of the functions that relies heavily on the geometry transform engine. And a lot of that is macros and other things that are not able to be decompiled currently with M2C, which is the automated decompiler used by decomp.me and used primarily as a first step for a lot of the Soten decomp. Let me find chat. Oh, there's chat. Excuse me. So when we're decompiling, what we do is we take one of these overlays. An overlay is just a file that exists on the disk, in this case the PlayStation disk. It could be the PSP disk. It could be part of the application bundle on the Xbox 360. I haven't looked at the structure of the the Requiem collection. It's in the app bundles for mobile. For PlayStation and PSP, what happens is these overlays get written by the game to certain addresses in memory, and they contain sprites, data, functions, other things like that. And what we're doing is taking the code function part of those files and trying to reproduce C code that will compile back to exactly the same binary file that was originally on the disk and shipped with various versions of the game. And so to do that, we're looking primarily at the PlayStation version of the game, but we also look at the PSP version of the game. These were built with different compilers. PlayStation was built with an old version of GCC. The PSP was built with a version of the MetroWorks compiler. A lot of the code is the same, though, and we're able to compare the binary representation of those two compiled versions of the game to get back to the same C source code in most cases. So what we've been doing yesterday was looking at one of the Sword Familiar functions. You can have one familiar loaded at a time. The familiars represent a particular overlay that gets written to the 8017 offset in memory. And there's a bunch of different functions specific to each familiar. This one is related to drawing, and maybe we should spend some time. I don't have a USB cable, unfortunately, over here that I can use. I was going to say maybe we should spend some time playing through different scenarios and finding out when this function triggers. We'll see how the day goes and if we can get back to that. So one of the issues with this particular function that makes it a little more difficult than some of the other things that we've been working on is we have a bunch of variables that are written to the scratch space. What I may end up doing here is giving these a symbol name, and then we can build a structure around those to make that a little easier. And I think if we map a symbol specifically for this overlay, that it shouldn't conflict with other names for the same symbol. Basically, it'll act as an alias. But then the other issue is these function macros that look like functions, and on the PSP they are functions, but for the PlayStation these are actually just inline assembly. And so what M2C is not able to decompile these. just gives us errors. And so what we have to do when we're decompiling is match the instructions that are here. I'm going to go down to line 210 in our assembly view here. Match these instructions. So the load upper immediate, add immediate unsigned, these instructions. These are specifically for getting the address of this global variable. And then the LWC2 instructions below it, those are part of the GTE LDV0 macro. This GTE RTPS, this is actually a function that is specific to the PlayStation and part of the coprocessor, the GTE coprocessor. And then we kind of continue down. And so here, for example, this looks like potentially we should be loading an address, but a value is being loaded instead. I looked at this briefly earlier. So when we're decompiling, we're looking at this target assembly. This is what we want our C code to compile to. And then we have what our C code currently is compiling to. We have a bunch of macros here that are possibly intractable if you're just getting started. Okay, and this ended up working here. So this was a reference to this this particular value. So we're grabbing a variable from the scratchpad, which is what SP is for. This macro just casts an offset in the scratchpad to a particular value. So what we know so far about the scratchpad for this particular function, and this might be, like I said, this may be worth creating some structures and an alias here. We know that the first 4 bytes are a signed 32-bit value, which appears to be a counter. And the next 32-bit value is a pointer to a primitive. This looks like it is something at offset 8, which may end up being another pointer to a primitive. We have other things that are also at offset 8. That may be worth looking at. I don't know why originally this was pulling from this global, but it doesn't seem related to that. Nope. That one. And so I'm going to go through and try to work through as many of these as I can. So this was a mistake. It looks like there may be too many of these. Because these have to be manually decompiled, sometimes it's difficult to figure out what exactly should be pulled. A lot of these are these must just be copy pasta errors. We'll fix these, and this is currently the PlayStation version of the game. And what I've been doing with these is kind of flipping back and forth between the PlayStation version and the PSP version. The PSP version can help with some of the structure of these calls, and then the PSP version, or sorry, the PlayStation version gives us more of a ground truth for these, each of these inline assembly macros, which just look like function calls on the PSP side. So most of this is actually going pretty well. So this is, I have this as offset 8, it should be offset 4. And then down here, this looks like this one should be offset 8. Maybe this one is offset 4. So this part can be more difficult on the PlayStation side. So we have a loop, and this is written as a do-while loop. My guess is that it probably should be converted to a just a standard for loop. This happens quite a bit where the optimized GCC version will turn this into a loop because it knows that the initial condition will never be false. So this ends up being more efficient. But it can be difficult to read in the assembly because we have this do statement, which looks kind of like conceptually, when I think of this, I think of it as a do nothing, just fall through, basically a label for the end of this while, an anonymous label. But when GCC compiles this, it attributes quite a bit to this particular line in the code. Things that obviously the do does not represent. On the MetroWorks side for PSP, we get a little more clarity there. So what I'm going to do is rewrite this as a for loop, kind of trying to pay attention to all the stuff that's going on here, and try to figure out whether or not I can see if this is getting closer or further. I do notice some things offhand. Anytime we see this 1F80, that is going to be a reference to the scratch pad. It'll be a little harder to identify. It's load up or immediate 1 on the PSP. Just different places in the address space for both consoles. And then we have 18, offset 18 within that, and offset C within that, or what is C12. And those aren't being referenced up here at all. So there's some stuff missing from this. So actually, here's our 1C here. So let's try to figure this out and try to determine what is missing. So we have to see where T7 is being used, for example. I don't see T7. Well, not until much further down on line 277. So here there's a reference to T7 that we're not pulling. So let me rewrite this as a for loop first, and then we can move on from there. This also allows us to get rid of this temp v06, which is no longer used. so let's go back up and see how that affected the rest of this. And there's really not much change up here. There are several variables that are being preemptively loaded prior to the loop starting. So 4.8, C4. So here's that 4.8. Here's the C4. Those aren't changing, and so those references are being stored off in a particular register to be used later. There's not much on the MetroWorks side. We can look at registers and say, oh, that's being used for a variable, it's being used for a return value. On the GCC side for PlayStation, we don't have as much consistency for what registers are being used for. Occasionally we can, but in this case, these temporary T1, T2, the optimizer has decided to use those for caching values that aren't actually being cached in code. One of the things I pointed out early was this T7 that's being used from offset 18. Sorry, it's offset 18 of this 48 variable global. This A3, let's see where that's being used as well. So down here on 243, there is a store to A3 that's missing. I see. There's a bunch in the middle that's missing. Morning, Outcome. Morning, Nate the Great. Good to have you back. So we're still looking at that function from yesterday, where lots of inline assembly. I did go through, and I might start a new scratch for the PSP. So I have a few things here that need to be resolved. It looks like those shouldn't be raised anymore. I spent some time yesterday getting symbols for a bunch of these, and so we can actually get a... Let me just see if that... oh, it's not compiling anyway. So we're a little closer. I was at 63, up to 63.6. Let's do that and see if that looks any nicer. So I'm going to go over to the terminal, and our PSP function is named something slightly different because it is in a different place in memory, and that's how functions get auto-named. Oh, I ran into this yesterday as well. So this does exist. I thought it was in a file of the same name. Oh, maybe I did a clean. I don't know. So I'm going to actually, I don't need that. I'm going to split. All right, and now we should have that file. Nope, still not. So where are you? We do have a unique value in this function, which is helpful when looking for PSP EU. That's where I went wrong, and I didn't remember that from last night. I find unique values, if you have them or can find them, those are the easiest way to map functions between systems. In this case, that 3E8 is an argument to setting the screen geometry, and whether or not then there is a compatibility layer for something like the Xbox 360 version, which was recompiled, does that compatibility layer exist where that value would still be used, is an unknown. It might be interesting to look at, though. All right, so I'm going to go back to Scratch. Sorry, not Scratch. Go back to decomp.me. And I'm going to create a new PSP Scratch, and I'm going to use the same context. Maybe we'll see some benefits. There's a couple other things that I'll point out that I found along the way as well. So we do have decompile. There's some symbols that I still haven't mapped yet, and we can look at those as well. I'm going to copy this one over. I guess first I'm going to grab the new PSP link. Save that. I'm going to delete this old one. Goodbye. Cornholio. And paste that one in and see we're 63.98. So oddly, the other one was at 64%. So there was something I missed along the way, but that's okay. We'll figure it out. So not all of these were mapped. I'm getting a little closer. So I might go through and do some of that mapping now. One of the things I noticed, there's two calls to this 04C. And if we look at the original, it's so 430 should be STXY. There's a second STXY that is not clear what it is, but it's not showing up either. Those may be combined, or there may be an assembly macro that I don't have yet from the SDK, and that might be worth looking at. But then when this set flag function is called, there's always two of these 04C calls. And so what I did is basically just create the macro for set flag to do two of those calls. There wasn't anything on the PlayStation side that that matched having two identical function calls in a row. So I like that idea of using a macro in its place. I did spend some time, and I started typing a message in the Decomp Discord, seeing if anybody had gone down this path yet. But what it looked like was we don't have any currently decompiled PSP code that has mapped any of these symbols. So we're a little blind when doing this on the PSP at the moment, at least for the stuff that's been checked. And it certainly is possible that somebody else has looked at this. I was going to go over to the other terminal, but I don't have that in place. So let's do this. I'm going to I'm going to look for the instructions for this STSXY and this STXY unknown, which is a new macro that I created. And what I want to do is see whether or not there is a existing macro for that. So to do that, either I want something that, no, these do look like two separate things. Well, they are two separate things. I want to find a macro that is calling the SWC2 instruction along with value immediate 8. Nate the Great with the recruiting. Thank you, Nate the Great. I'll accept the sponsorship dollars later. Joking, of course. So let me do that. I'm gonna. What's the best way for me to do this? Let me. Let me hide my terminal and grab that. Mission 5. Oh, this is interesting. I don't normally SSH into my Mac. And I don't know if it's part of a recent Mac OS security, but SSH'd in, I don't have the ability to read files. Well, that's wild. Okay, I'm not going to do that. Weird. I'll do this instead. All right, so this is called inline-c.h. This is from the 4.6 release of the PS1 SDK. So what I'm looking for here is whether or not there's a SWC2 macro that is going to be writing or using the value 8 as its first argument, and I don't see that. What these immediate values do offhand, I couldn't tell you. Let me look for that here. I know that 14 exists. So let's look at that. I don't think /s works by default in grep. I'll just do a dot star. Oh, did I? That's why. Okay, so here are all the SWC2s. Let's see if we have an SWC8. There is. That is an inline O.H. So this is STDP, and there's a move instruction immediately before it. I don't think that exists in what we're targeting here. It is possible. Oh, there was one I missed in inline C as well. GTE STDP. So this is a function that we haven't imported yet. I missed it when I was grepping around. So let's add that macro to the context. And so this is the first time that in the Soten Decomp project that we've come across this. Let me look and see what this is. So this was originally STSXY. While I have this open, I may look to see whether or not this is documented. I couldn't find anything about most of the GTE macros in the libref documentation. And that looks like it works. So now we have another another new macro. I'm gonna close all that stuff down in terminal and come back. So one of the if you're paying close attention, you may or may not notice that a lot of my computers are named after places, and that has been a naming strategy that I've used for almost 20 years, is to give each of the computers a place. The only computer that I have, or the only place name that I have that has been moved from one computer to another is, actually I have two now that I think about it. We have a file server that has been around in many names many machines for about 20 years. And it has maintained the same name. So I'm going to go to libgte and look for the STSXY. And I'm going to add this other macro here. Oh, didn't copy the whole thing. And then I guess my phone. My phone is the other one that I have reused the name on the last two phones. At one point at work, I had a those are your home name servers. Entropy Gravity Well, or those are your work name servers? At some point, I named my all the computers are places, typically places my wife and I have been or enjoy, and let me make sure that there's a PSP entry for this as well. I guess we don't need that yet. At some point, I ended up calling my phone Moon, and then I got a work phone, and I called that Death Star. And I called it Death Star because it was not Moon. That's no Moon. I see. All right, so we have our macro added here. And we have it added over in decomp.me. And then the difficult thing for the PSP version at the moment is every time we have one of these macros, we need to make sure that it either gets added as a stub or if there's no other macro in its place. That all should be fine. So I'm going to... there's going to be a bunch of cleanup now related to this, but I think a lot of that is looking good. One thing I noticed on the decomp for the PSP, it looks like this was happening inline, and I wonder if it's time to create a struct for this. Might be. Oops. Still needs to be a reference. If I'm flipping around too much, let me know. There's like a million things to fix. I do need to get rid of this unknown macro. So that one is no longer relevant. Right, that's the one we got rid of. All right, so now all of these STSXY unknowns, those are going to become STDP. And many of them are going to have the wrong value. But so now, except for registers, all of this block here is looking really good. This is definitely slow going, but it's nice when it's working out. So 149. I've dealt with this, it looks like a couple times. So it looks to me like this DO is a pointer. So let's fix that. And the way I can tell that is what operations are being done between what I have and what is there. So here we're loading. So when we load pointer values in MIPS, we only have 16 bits per instruction to load. And so when we need to load a 32-bit pointer or a 24-bit pointer, depending on what we need, we have to do it in 2 instructions. And typically, that's loading the upper part of the 32 bits and then either adding or ORing the lower 32 bits, or the lower 16 bits, sorry. If we have something like this, though, we're loading the value, load word. So we're loading, or we're storing the upper 16 bits in the first instruction, and then we're adding the lower 16 bits, and at the same time loading that. Let me see what you sent me, Nate the Great. Oh, interesting. I do not know what this is, but I will take a look at it in a bit. So I'm going to take references to both of these. I do need to fix this. And it looks like I have another declaration which doesn't match. And yeah, and so those instructions correct themselves once we're taking a pointer. All right, continuing down. Here on line 155, this is another one of those cases where there is a value being loaded, this time at offset 24, hex 24, so 36. And it's not currently present. Oh, it is actually down here. But it's not being loaded in the correct order. Here we're missing the set DP. Happening out of order, sorry. And so as this is kind of coming into focus, what these things are, it looks like if I were to create a struct for this, and like I said, it may be time for that, offset 4, we could probably reliably call DP, offset 8 flag, size of something, TZ. I don't know what TZ is. But so we can start naming these variables or fields at offset. This is pulling from a offset 24. This could probably be rewritten, but it's using the I value. This first value on the scratch pad we could probably call I because it's used that way so much. And it might be worth doing that. So what I want to do is see if I can give a symbol name to that scratch pad value, even though it may be defined already in a higher overlay. And still make Scratch happy. I know if the symbols are in the same file with the same address, Splat is not happy. But because this will be at a higher level, let's see if it'll work. So we're looking at familiar 4, which is the sword familiar, and I want the symbol table for that. And we'll call it the sword scratch pad, and it is going to be at 1F800000. And actually we can do a few things here. We can call that I, because we know that's I. We know the second value, that 4, is a primitive. And basically we can just kind of go down through each of these and give them names. And this is how we do the struct access as well. I thought so. All right, so let's look at that again. So offset. Offset 4 is the primitive. So this is a pointer to this primitive. Offset 10. I'm sorry. Offset x10 is the primitive. This stxy new, I need to get rid of that. That's gone. So 04, sorry, I didn't have the right screen up. 04 is, we'll just call it DP, and 08 is going to be flag. Flag is going to be a 16-bit value. So I've been writing it as a 32, but it's actually a 16-bit value. Offset A. Oh no, it is. Sorry, it is a 32-bit value. Offset C is this SZOTZ. One. And then offset 10, it's going to be prim. I think we have a few more here. Offset 14. So this is a max value of some kind. What I don't know yet. We'll call it unknown max. All that beer and otherwise fun. I don't know if you'd be running like Alucard. Maybe you would. Or so this also is a max. This is a max of 3 values. Of what yet? I don't know. I'm trying to find the rest of these. I think this is a good start, though. So let's see if Splat is going to yell at us, because we have duplicate symbols for many of these addresses. And hopefully it doesn't. So I'm going to do a make extract and see what happens. It work? It appeared to. So I want to look at our function, again, the assembly for our function. And what we should see in place of many or all of those one F80. No, is that right? Yeah, one F80. Yeah, I was hoping that these symbols would have mapped, but they didn't. That is a bummer. What course or program? If you're a noob and you wanted to learn. So I think that is a super tough question. Because I know from other work that you've done, you're not necessarily a complete noob. So like if it was somebody who's never done anything before, and it's been a long time, but I liked Y's Poignant Guide, but I also like Ruby. And then his hack environment around all that was really good. Nowadays, yeah, and that's kind of 15 plus years old as well, and I don't know if it's maintained anymore. Yeah, I'm not sure what. So I have, I have biases for sure. When I went to college, we were basically taught in C and C++. And one of the things that you get out of C and C++ that is good, I think, when moving to like computer architecture and some other computer concepts, is that you have access to pointers and a lot of really low-level memory access. And you don't get that necessarily with, a few years later, schools moved to Python and Java. You don't necessarily get that with Java or Python. But from the other side, if you're looking at like algorithmic fundamentals, the language doesn't matter anymore. You just need something that you can implement languages in or algorithms in that at least has references, and whether those are pointers or something else doesn't matter. I think there is a difference between learning how to program and learning the concepts of computer science and learning a programming language. And I would definitely advise people to learn how to program and learn problem solving and focus on that as opposed to learning a particular programming language, because once you know one programming language, learning a second is relatively easy and most of the core concepts are the same. So if you know a language, doing algorithms or data structures, finding a course in your language that you prefer about those things is pretty valuable. I did interviewing for a long time, hiring candidates both fresh out of college as well as who had been in the industry a long time. And really, like, data structures and algorithms were core things that I always looked for when I was hiring people. And it's much easier. It was definitely much easier for people coming out of college, master's degree, whatever. They had just spent a significant amount of time theoretically looking at hash tables, lists, computational complexity, all this other stuff that you don't necessarily get in most day jobs. And so those people actually did quite a bit better often than people who had been in the industry for a while. So I'm bummed. I'm bummed that these symbols didn't end up getting extracted. I'm going to, what should I do? Should I do why? I'm going to open that up again, and I just want to make sure that I didn't do anything stupid here. Yeah, so this is matching. Let me look at the parent. Yeah, we don't specify a parent in the scrat or in the splat config. I am going to look at why splat doesn't. So the first byte of the address on the PlayStation specifies an addressing mode. I don't think I have a table up at the moment that describes those. I have one open somewhere on one of my tabs. I'm going to go back here though. Let me think though about what I've actually struggled a bit to figure out. So I'm going to put the latest on the PSP and see. The PSP is still just hovering around 63. I have thought for a while, because I have kids that are of that age, where I had started getting into or having an interest in programming and trying to find resources for them as well. And so a lot of kids use Scratch, which I think is good and does focus on algorithms. What I suppose it's like any other programming language. When I come to it, how you're limited in some cases of thinking about a problem may or may not be difficult. How about you, Chad? I'll open it up to you. Anybody done anything recent in programming education that you'd recommend to one person or another? In late career, what I've found in general is there's just a million different frameworks and libraries and other things like that, and staying up to date on a lot of that becomes more difficult. So here, what I'm looking for is like I know VARSP is used as I in a lot of these cases. So is it more likely that this is just being pulled as this index and there's not a separate variable? It didn't seem to make a difference, but I'm going to keep it that way. And then here, we have these three different arrays. And how are they being used? I'm going to go over to the PSP side, flipping back and forth, and see if I can learn anything from there. Dark mode. Redraw. So this area definitely is not doesn't look correct. There is something being loaded from Scratchpad offset 0. And then there is a global being used here instead of well, there's a global being used that I don't have. So these, I don't know if this is going to work, and I suppose it would. Yeah, these are being referenced each time. Save that, go back over to PlayStation, and we're looking at or around 182. So, so here's our global that's missing. Nope, maybe not. I'm not sure. Go back here. Oh, yes. What is happening is these aren't actually temporary variables. These are being accessed, it looks like, each time. And an XY pair is being pulled. So let's do that. Let's let's see if it'll let me do that. So we want something like this. Go to 182. Looking for the declaration for that. There is none. So all I know about this at the moment is that it looks like a XY set of XY pairs. So I'm going to say that it's a sine 32 array. We can go look at the if this matches, I'll leave it. Otherwise, we'll go look at the data and see what the data looks like. All right. So this is being redeclared. I think that I had a declaration elsewhere. Oh. It is an XY pair. Good. So yeah, I had to add that earlier. So we have a XY, and we can say val here. And this is being stored into V0. Oh, this is weird. So this is being loaded as a 32-bit value. So we have the low macro to do that for us. It's not being stored as a temporary variable. This is like the grossest thing I've ever seen. And then the same thing is happening again down here, except we're getting the Y portion. Is that right? We have a sine extension. No, maybe it's not. Maybe it's not doing that. I read that wrong. Not as gross as I expected. All right, so we're loading a word at offset 0. That suggests to me that it's a pointer. I don't think this will make a difference. So I think that this is a pointer. And unfortunately, it's going to be relatively difficult to undo. Actually, no, it's not, because this makes sense up here then. Let's look at normal clip. That was actually... no, that's why I did it that way. This could be... yes, okay. So here, Sorry. Normal clip hadn't been imported yet, and normal clip is interesting in that it takes 3 XY values, but it takes them as a single long. So X and Y are both 16 bits, and so it packs them into a 32-bit value and then basically returns something similar. When I was building this new struct, which I think is only used here, I built this out, but what I think this was is a pointer to a point 16. And so this will break a bunch of stuff, and I'm going to have to copy this over to the PlayStation side and break a bunch of stuff over there as well. And hopefully I will work this out. So what this... I called it XY. This is a little strange, but basically I can dereference these. And then down here, I have to point to these instead of... And all of these down here will be broken, so I'm going to comment these out for now, and then check them again once I get this compiling. So let's see here. So we have a few additional load words. Let's try putting this in line. Yeah, I think these other variables should be like that. So this may be about right. Let's try the next set of these and see if that works out as well. To get rid of these. So this actually is looking, I think, pretty good. It's not, it's definitely not the most beautiful thing, but The other way that I like learning new things is finding open source projects that either I like or are well written. Yeah, so this is all lining up really well. Down here, we're gonna have to basically do the same thing over again. So I like finding open source projects. So Tmux, I think, is written pretty well. Any of the BSD stuff is usually written better, I think, than the GNU stuff. Nginx is actually written pretty well, pretty easy to follow. So finding projects like that that are very readable, and going through and learning how they do things. Okay, so this is mostly okay, not perfect. This prim is going to go directly to that offset again. One day being able to reference a struct instead may make that easier to read. What did I do? Oh, I see. Oh, I know, I can use option to move those around. And I probably should. Look at that. A bunch of stuff falling into place. Lovely. Happy about that. Let's see what if the PlayStation loves it. The PlayStation liked it. I wouldn't say the PlayStation loved it. All right. So let's deal with this loop. Look at that over on the PSP side. And this doesn't seem to exist in the same form over here. And I think this is going to be the same. This may be a ternary. Oh, I just noticed your comment, Project Omega. Good to have you back. Yeah, this is not. So this bit of logic here is not used, at least not on the PSP side, or maybe afterwards. Let's look at the decomp. So here we're incrementing I by 4. It does look like there is some business around it's the same shift up here. So let's pull that down. And then it looks like A0 is what's being used. They call it varv1. The shift is duplicated. I'm still not matching quite right. It does seem like a lot of this, possibly this portion is calculated first and then the index is calculated. So let me do that. We need a temporary variable. Okay, so that looks better. So we're doing this calculation. So 18 and 14 are maxes of two different things. I don't think 1C has come up yet otherwise. And then we're trying to figure out where that's going to go. It looks like there is an A4 in here or A0, which is the value 4, which needs to be accounted for. And yeah, it seems like a superfluous assignment. A0 is not being used in exactly the same way, but so A0 is being assigned here and then just being overwritten later. There is no other variable that I can put in that place right now, but it does seem to be a throwaway value. Well, let's save that. So, as I mentioned, this is that actually was much worse on the PlayStation side. So let's see what the issue is here. 293. Where is my? Oh, there it is. Where'd it go? So there is some out of order loading of this immediate value 38E3. 296. I'm not sure what the meaning of that value is. It's being used in V1. 38E3. It's part of the division down here. So if I replace that, it doesn't look like it's that part that the PlayStation is upset about. It looks like further up. So let's look at 295. So this particular line looks like it's being calculated well. There is a plus equal to 1, or increment to V0. V0 is the result of this subtraction. Oh, the addition of 1 should be on this line as well. I see. So what's happening is GCC has decided to take the value of n, add 1 to it, and then be able to use the branch greater or equal to 0 function. But the original is using signed less than immediate. No, actually, that's part of the loop. I don't know. All right, so we're definitely a little closer. But this one is going to be a bit more work. Definitely nothing free. I will come down here and fix some of this briefly. And again, I don't know how some of these ended up the way that they did, but we can fix them and at least get that cleaned up and get some of this other stuff matching. Let's go through. I think basically for all these set DP functions, we're going to be doing the same thing, and we do this same thing over and over. Now let's get up to line 266. There was some issue earlier. It looks like this STSXY is probably wrong as well. I think what I was running into is something needed to use that that A0 value, and so I might have forced it in there to ensure that this other code didn't get eliminated. I'm going to do a quick search for those, make sure all of those are the same. So this doesn't need to be a primitive. So that got us a little closer as well. And I'll get back over. Further on the PSP. That's kind of funny. Let's go down to the bottom. So down here, this is the set flag function. So it's no longer getting called twice. And so what that means is on the oh, it is getting called twice. It's this one here that is not getting. So we can put something in here to hide that. That's nice to find. So nice to find little logical things to modify. So this is pretty common when you see offsets that are backwards in memory. Often that these are being assigned together. And the hint that we get is that we're using the same register for the immediate value with the unoptimized MetroWorks compilation. If we have two different ones, we're going to see two different ones being loaded. So that's a nice, easy thing to fix while we're in here. So there does definitely appear to be cases where this set DP is not getting called on the PSP side. And so we'll fix that. Ooh. All right, so no change here. I'm going to look at a few other things and just go over where the sword familiar is, and actually maybe look at the demon familiar a little bit, because that looks like it was recently finished. I haven't seen a lot of these same geometry patterns in other overlays. So I am a little bit surprised that we have this new code. I mentioned in earlier streams that this does look very different from other code that I've seen, and was this a different developer? Was this what caused this to be so different from much of the other code? When I extracted the PSP version, I got a bunch of extra code that interferes with the build, so let me get rid of that. All right, so we're building okay. Let's see if there's any of these GTE macros in the demon. No. And I don't really see these in any of the servants. The one place that has used these quite a bit is like Richter's what is it? Item clash for the cross sub-weapon. Uses these quite a bit. It does look like there are other places as well that are using these, but we obviously have a few things that are new to this code base so far. Let's see what can be added. So I have spent a small amount of time, and I mean very small, starting to look at importing some of the data. There is a balance between what data can be imported versus code being imported. If I were to speculate as to what some of these are, to me these look like quads of 16-bit values. This 224, I believe, is actually used here, isn't it? Yeah, it is. And so looking at what do we have 224 set at? We have it set as a sine 32. That's obviously not right. It looks like it's quads. So we know that this is quads. So now this is a pointer to quads. And what is this pointer being used for? It's being passed to LDV 0. And so those are likely two XY pairs. But why? What does it mean? Not sure. So we will come back to that in a little bit, but I might spend some more time importing this data. Some of these are difficult because these are being referenced as words. The byte order is backwards. So we have F1FF as a 16-bit value, and then 2D00 as a 16-bit value. And it's, well, I won't speculate any further on those, but it could be that they are actually bytes looking at it a little closer. FF being -1, F1 then being negative, what, 13, 14? -14? The scale of that, I think, makes more sense. We'll come back to that in a bit. So what we've been doing is decompiling the functions in the sort familiar. One of the more difficult ones, specifically related to drawing something. We don't know what it is. Something with a lot of geometry using PlayStation-specific hardware. I will try to set up a gameplay loop for tomorrow, so we can step into this function and see where it might be being called. If you want to know more about decompiling Castlevania Symphony of the Night, go to soten.z.dev. I'm a contributor to this project. I found it several months ago and have been contributing ever since. And I thought it'd be fun to share some of that progress with anyone who's interested in coming along on this journey of decompiling a somewhat retro but modern tooling game. You can find a link to GitHub. You can find a link to Discord server if you're interested in more of this decomp. Follow, like, subscribe, and I'll be back tomorrow. I'm here 4 days a week, Monday through Thursday, 12 p.m. Pacific time. I will see you all tomorrow. I appreciate everybody in chat as always. Adios.